Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I am Michael, founder of PG Mustard, and as usual I'm joined by Nick, founder of Postgres AI. Hey Nick, how's it going?
Hello Michael, going great. How are you?
I am good also. What are we talking about this week?
We're talking about what's written on the cover.
Are we going to write LWLocks or lightweight locks as like a full word? What do you think?
I like the shorter version, of course. There's also a question to write 3 uppercase letters or everything lowercase. Yeah, lightweight locks, it's even hard to pronounce. So, but LWLocks also not good, right? LWLocks. I like some systems call it latches, you know?
Latches, yeah.
Yeah. Why Postgres doesn't do it? Maybe because of Linux, or I don't know.
Naming things is hard.
Yeah. Because we have confusion sometimes when we say just logs. You know, like when we say backups or logical backups dumps.
Yeah.
Here also logs. There are 2 types of logs. Well, there are more types of logs, right? But there are 2 major types.
Categories.
Yeah. Is it category or type in PGStat? In PGLocks?
Good point.
Yeah,
maybe types. I don't know. Another loaded term. Types is another loaded term.
Or mode, or maybe mode. Let me just check right now. Maybe it's called mode in PGLocks. I'm constantly confused about. There are some terms like class, type, mode. Like they can be, like they are quite abstract, right? Yeah, it's called mode. In PGLocks, it's called mode.
Cool.
But PGLocks is about heavyweight locks. We are talking today about lightweight locks, right?
Yeah, we did a whole episode that we just called locks because that's generally what they're referred to, the heavyweight locks in Postgres.
If there is no additional word, it means heavyweight locks. So yeah, and why so? Because heavyweight locks, you can name them just logs because they are closer to user, right? You can see them in PGLocks, for example. You can sometimes, not always, but sometimes you can acquire them directly using just log SQL command, right? Just log table name. Or select for update and you see it in transaction being acquired some logs, right?
Yeah, I also think in general more people come across them because they affect you at earlier stages in project lifecycle. Like you don't have to be at such extreme scale to start being affected by them or having to be aware of them.
Yeah, I agree. In general case. Because in some cases, for example, if you have read-only workloads, that's it. In read-only, you don't, like, you have heavyweight logs, but you won't notice them because they're like access share log, that's it, right? But if you have really a lot of TPS, you might start observing some lightweight logs. Right.
Yeah, I was thinking even like schema changes though, like even in read only.
This was edge case.
Fine.
Edge case. Yeah. In general, I agree with you. Heavy logs, you bump into them sooner. Schema changes is a great example. Yeah.
Cool. So starting with the difference between locks and lightweight locks is probably great.
Yeah, let's talk more about differences because there are important differences to understand and feel and take into account when you develop things or tune, optimize, scale, migrate, I don't know. So heavyweight locks are acquired during like SQL operations and they are acquired for like database objects, like relational level locks. By the way, this is super confusing. I'll be talking about heavyweight locks a little bit, trying to make it shorter. But as you know, I write again almost every day. I skip some weekends, but I write Postgres marathon posts again. And many days I already sit in between heavyweight locks and lightweight locks and research one of lightweight locks, Lock Manager, right? So relation level locks, it's quite confusing name because they are called in documentation, they are called table level locks, which is misleading because they are also this type of like The same thing, and inside documentation, it becomes clear that indexes are also involved, and materialized views and views, and so all relations. Sequences are also relations, right? Yes.
I never really thought of it like that.
Well, if you check PG class and real type, I think S is sequence. Maybe I should check again. Should we develop a habit to check things right online?
Why not?
Yeah, so I will be checking, but meanwhile, you can acquire logs, heavyweight logs on tables, on indexes, on database, right? Like even higher level. You can log the whole database. And we know the recent problem when Recall AI blog post, right? Our clients, they posted about database level log acquired when notify happens to establish sequential notify events at commit time. And also row level logs.
Yeah.
Tuple level or row level. Let's leave it for another time. So you can acquire logs on database objects. These are heavyweight logs. Documentation is also confusing because it says explicit locking, although most of the cases where you have it, it's implicit locking. You say alter table and you don't say lock table, you say alter table. So it's actually implicit. This I have also always like some shift in my brain when I need to Google documentation for heavyweight logs. I just remember I need to search. I need to ignore the fact that I'm going to look at explicit locking documentation, although I need implicit locking documentation, right?
By the way, before we move on, I checked PG class, and you're right. Sequences are in there, and weirdly, the rel kind is capital S. All of the others are lowercase, I think. Well, the ones I can see anyway.
Does it mean something?
I don't know.
Yeah. Oh, by the way, explicit locking documentation, it mentions that you can lock indexes with access share lock, for example. But you cannot do it explicitly. You cannot say lock and index name. So I'm pretty sure you cannot do it with sequences as well. Yeah, anyway. So these are heavyweight locks, right? So you basically, your actions, I mean your SQL, this is what directly creates heavyweight locks. And why is it needed? Because we are not working in single user mode.
Yeah.
We need to protect resources from concurrent operations, reading, writing, changing. And usually we don't need to protect from reading. But while somebody is reading, another backend shouldn't modify it, usually, right? Or, for example, if you read from table, dumping it, for example, other session cannot modify, like add a column, for example, cannot run DDL, for example, right?
Or drop it, for example. Yeah.
And the important thing about heavyweight locks compared to lightweight locks is to understand that once a lock is acquired, it can be released only in the very end of transaction, commit or rollback. That's it. Only two options to release this lock. You cannot release it midway, right? And this is super important for understanding always. It means that transactions should be shorter, right? So your actions won't affect others. Or chances to affect others would be lower, right?
Or time that it affects others is lower, right?
Yeah.
Because you will affect people just for less time, and there's a point at which that becomes unnoticeable or acceptable.
Yeah. Or won't affect at all if they come a little bit later. But if you change something, or even if you read something and keep transaction open for hours, it means nobody can modify this table, no DDL is possible, auto vacuum cannot do some things and so on. Like it's bad.
Yeah, so, it's worse than that, isn't it? I know we've talked about this before, but if DDL comes along and doesn't have a lock timeout, then actually you can suddenly be down. So
because this is also a good point. So heavy locks, they have this ability, like this property to be acquired. Release happens only in the very end. And what you say also good point. There is a lock manager. By the way, I couldn't find definition of log manager. Nowhere. Like it's obvious, right? Even in the source code, it's not defined, which is interesting. So log manager is responsible for managing logs, heavyweight logs, right? And backends can form a queue of waiting for log acquisition. So if I'm waiting to acquire log, some other backends can be waiting, and they like ask where is the end of the line and go there, right? So it's just natural, like in the order of first like in natural order, right? So unlike lightweight logs acquired and released very quickly. I think documentation and source code I mentioned, it's like dozens of operations. Unlike there is underlying concept of spin logs, which like few operations only, like few instructions only. Lightweight logs are bigger, but it's very fast as well. Like acquired and released, and they don't wait until the end of transaction because they work in lower level of abstraction. It's not closer to user; it's closer to resources like memory, right? So, and their main purpose is to protect some physical resources like parts of the memory, shared buffers, and so on, right?
Okay, yeah.
Like these things, and so they can be acquired and released quickly. There are only two types: exclusive log and share log. Unlike heavyweight logs, we have a list, and the interesting relationships between different ones, right? Here it's only share and exclusive, shared and exclusive. Shared logs don't conflict. Shared lightweight logs don't conflict. But exclusive log cannot be acquired while share log is still running, lasting, right? It should be share log should be released first, then only you can acquire exclusive log, because exclusive log is needed to modify the resource, right? Share log is needed to protect for reading. It's saying, I'm reading, don't change it because I'm still reading. And when I'm done, you can modify it, right? So this is lightweight logs. And that's why they are lightweight, because they are much shorter living, right? So these are main differences between them. What else?
Maybe types of lightweight logs, or like, forgive the word types, but you know, what should people be aware of? Because I've only really come across one type, because that's the type that seems to cause the problems. But what should people be aware of at least?
Types, modes. I struggle. Like I'm mixing these terms, and it's really hard to distinguish between them. So, if we talk about types, exclusive and shared, we just covered it. If we talk about different like kinds, or let's say wait events we observe in pgset activity. Pgset activity is the main cumulative statistics system view. Everyone should learn about it, right? It's super important because it shows what's currently happening in database. And there are two columns called wait event type and wait event. Also, by the way, slightly confusing because the word type is there and so on. I would prefer, it would be good to name that thing like classes maybe, or category, I don't know. Because type word is so overused, overloaded, right? Anyway, wait event type can be, I think there are less than 10 types. And two of them which are most interesting today is log, meaning heavyweight log, and LWLocks. And wait event type LWLocks, you can check documentation. There are many dozens of wait events for LWLocks, meaning that we have a lot of kinds of LWLocks. These kinds, types are only exclusive and shared, but these kinds, it's classification with respect to the resource we are looking. For example, log manager itself, although the main purpose of log manager is to manage heavyweight logs, when it does it using a piece of memory, shared memory. Special piece of shared memory called, it's called main log table, right? It's big piece of memory which is segmented, partitioned to 16 partitions starting Postgres, I think 9.2 or 8.2, 8.2 actually. It was very long. Num lock partitions, 16. And when a new information about heavyweight lock is needed to be written there, the partition of this main lock table where it needs to be written, it needs to be locked by lightweight lock, right? To ensure nobody else is writing to it.
Yeah.
So lock manager can have up to 16 lightweight locks, which are seen as LWLock lock manager. 16 because we have 16 partitions of this main lock table in memory. And how it works, based on, for example, for relation level locks, based on relation name, there is a hash function which understands which partition to use, determines which partition to use, right?
Yeah.
So the same table or index will always go to the same partition of all of those 16 partitions, right?
So this was a long time ago. So back in the day, I'm guessing this was one thing, and
Yes.
there was probably too much contention.
Before 8.2, yeah.
Yeah, okay. That's what you're talking about. Great.
Yeah, and this, just to, there is a confusion because there was another 16.
Yes, that's what I was
It's
thinking.
a different constant, which changed, that behavior changed in Postgres 18. This
is
behavior
fastpath.
hasn't changed. Yeah, fastpath
Yeah.
changed. This hasn't. This still is 16 partitions. And if you have a lot of heavy lock acquisition attempts for the same relation, a lot, I mean like thousands or maybe dozens of thousands per second. A lot, really a lot.
Yeah.
Then exclusive lightweight locks on the same partition will be competing. And while you are waiting, while we try to establish heavyweight lock to some index or table, but that partition is already locked by exclusive lightweight locks from different backends attempt to write heavyweight lock information about it. We need to wait a little bit. And this little wait will be seen as wait event type LWLock and wait event lock manager, right? Is it clear? Because we are we have weird combination of heavyweight locks and lightweight locks in the same topic here, right?
Especially because the lightweight lock manager is actually looking at heavyweight locks. That's the confusing part for sure. But I was just looking up in the docs in the table of all of they've called them types, wait events of type LWLock. And you're right, it's such a long list.
Yeah.
I think there might be 50 or more.
You will see checkpoint, auto vacuum there, but isn't it great that we don't observe them?
True.
It means it's quite well optimized, right? For example, you will find a lot of stuff. I see many of them. I do observe, not just lock manager. We saw many of them in production and yeah. Usually the rule is if you see lock wait event type, it means you need to go and think how to redesign your application. Because classic example is, for example, we are doing some billing system and we have a single account which needs to be updated for each transaction people do. I mean, financial transaction.
Yeah.
And this is a classic example when you shoot yourself into the foot because updating the same row will be hotspot, and you will see a lot of you see heavyweight lock contention because many backends try to update the same row, right?
Yeah.
So or you mentioned very good example. If you do DDL without lock timeout and retries, you also can have a chain of waiting backends which just wait until your DDL finishes, but it itself is waiting for some other select. And I see examples in blog posts. People I see examples. People try to explain this problem, but many of them involve updates, deletes. No, just select, DDL, and many other selects. You don't need even to update anything or insert or delete. That's it. Just select and DDL. And we see lock wait event in pgset activity. It's bad. But when we talk about and for lock you saw like it's a relation, object, page, also page interesting, tuple, virtual key, it's interesting. Advisory locks, it's kind of different thing. But for LWLock, we have a lot, and among them there is Lock Manager. I like the approach which I think RDS started, maybe not RDS, but they use it a lot, and I also started using it. We usually take wait event type and wait event to columns from pgset activity and write them with a colon in between. So it becomes LWLock colon Lock Manager. Just in like in texts where we discuss problems and do RCA or something. Yeah, it's just convenient.
Like a naming convention.
And I wanted to highlight that this problem, which related to both heavyweight locks and lightweight locks, in the name of it, we have the word lock twice. LWLock, Lock Manager. First time it's about lightweight lock, but in Lock Manager it's about heavyweight lock.
Yeah.
That's why the lock like is encountered two times. What else? Like we observed other types of lightweight locks problems. For example,
well, I spotted one in the list, subtrans SLRU.
Yeah, this is my favorite one. Although I must admit, I haven't touched this topic for a few years. I touched it heavily in 2021 when GitLab had the problem. And studied it. And since then, SLRU, it's simple, least recently used. It's small caches. Postgres have multiple of them. I think since Postgres 12 or 13, we have pg-start SLRU system view. You can see like counters of work of those SLRUs. But also SLRU mechanism got some handles. Settings, GUC, GUCs, right? People say GUCs. You can change them and increase it and to postpone this performance cliff. So I haven't seen them often since then. Like there are customers who usually read and come we help. We help easily. Like just try to get rid of subtransactions. Although, like I still think by default you should avoid subtransactions. But in some cases I already see they can be used in a safe way. You need to just understand the limits and then you can use them. For example, again, DDL, sometimes complex changes of schema. You don't want to lose part of schema. And this approach with attempts to acquire lock, how can you do it inside transaction? You need subtransaction, right? Because if attempt fails, you don't want to lose everything. You want to lose only the last step, right? And this is exactly where I think it's worth thinking about to use some transaction, but you need to understand like details. For example, you don't want to have a long transaction running on the primary in parallel to other table, by the way, not to any table. And replicas which receive a lot of transactions per second because they might be down because of the use of subtransaction, and you can see subtrans SLRU because SLRU is overflown. And again, when it's overflown, the lightweight locks acquisition, we see contention, and we see it as in pgset activity and wait event analysis as LWLock subtrans SLRU, right? There are other SLRUs, right? Mentioned like Notify SLRU. I'm pretty sure multi-exact upset, multi-exact member SLRU. Speaking of them, we had an episode about the case from Metronome, right?
Yeah, true.
Yeah, it was a great blog post. This is a great example how company can share with community what happened and others benefit. Since then, we had another new client we had, which came to us with very same problem related to multi-exact member.
Member exhaustion.
Yeah, exactly.
Wow.
Yeah. So it's also observed like a lightweight lock, multi-exact, blah, blah. There's a bunch of multi-exact lightweight locks you can see in the table. Another one is a very, very popular one is LWLock buffer mapping. So usually it's called buffer thrashing, right? When we like the buffer pool is not big enough and a lot of eviction happens and new pages are loaded all the time, and we see when, of course, when it's happening, to protect memory, Postgres needs to use exclusive lightweight lock when writing happening, shared lightweight lock when reading happening, and this is exactly when we can see some backends are a little bit waiting for other backends, right? And
Interesting.
And this is how it's seen.
So like if somebody's limited by the amount of shared memory or like shared buffers.
Yeah. Solution is simple. We need to increase the buffer pool. We need to fight bloat because this is what like increases this problem. We need to get rid of unused indexes and other things because they also contribute to it, right?
Unused ones,
of course.
Like, I was just thinking they would be evicted and not.
Think better when you change something with insert or non-hot update. All indexes need to be loaded to be changed.
Yeah.
And they contribute to this spam coming to the buffer pool and also to wall, but it's a different story. So that's why I think people underestimate how bad bloat is. I feel it like we have a new wave of companies coming for consulting to us, which I call AI companies. They probably are quite old companies, but they heavily transitioned to AI. And they have increasing data volumes, increasing workloads, and they underestimate the problem of bloat and unused indexes and index write amplification, all this spam coming to memory and wall, and it means backups, replication. It's like this thing is multi-sided. Yeah,
like cascades, doesn't it? Yeah.
It doesn't. Also, it's not a performance cliff which you like suddenly see and we have a problem. It's slowly like growing,
or like you sink into it slowly, like sand or like a swamp.
Yeah, and then you need to increase instance size or think about sharding and so on. By the way, I like sharding a lot, but I think in many cases it's just hiding the problem. It's just distributing the problem, and you pay not to solve problems. I for business it's sometimes valid approach, right? You don't have time to solve this, but we also can just implement automated procedures to reduce the amount of trash you have, right?
Yeah. I hear about it all of the time as well, even at smaller companies that just upgrade their instance, especially at the lower sizes. They just don't want to throw engineering time at it because
of surprised. I recently started asking directly on the very first call when we have consulting, like, guys, do you care about bloat and index health? And I usually hear no. And then it's our job to explain why, right? So it's easy,
but it's not. Yeah, bloat is not the problem. Bloat is like, well, it might be the root cause, but it's not the problem users see. They don't see. They're not.
Well, unused indexes also they don't see.
Yeah.
They created some indexes and forgot about it, right? Or redundant indexes. Same problem. I mean, similar in this case, but then boom, like buffer mapping, LWLock buffer mapping. Why? We don't have enough memory.
Yeah. Also, this might be part of it. I think bloat used to be worse. Like I remember before a few optimizations.
13, 14.
Yeah, before then, you could come across, especially indexes that were like 99.9%. You know, in extreme cases, you could come across very, very, very bloated indexes. It's just much less likely now. So I think whilst
it's less likely, but not much. Yeah, well.
Okay.
Only deduplication doesn't solve the problem when, Postgres B3 doesn't have merge.
But it does have bottom-up deletion. It does like a lot less splitting.
Well, if you have in the middle of B3 half-empty page, this space won't be used if you write if, for example, it's increment timestamp, right? You are writing to the end always. In the middle, nobody will write, so you have this bloat which won't be eliminated.
True. Until like, yeah. Anyway, let's get back to the topic.
Until reindex.
Well, I was going to say until like logical replication upgrade or something like that.
Well, yeah. Anyway, when you rebuild index anyway, right?
Yeah, true.
By the way, let me advertise something. We have open source component, which we just recently developed. It's now entering beta stage, and it aims to automatically rebuild indexes on any platform. Just reach out to me in any way. I will share details because we are looking for more cases before we move on and make it more publicly available. I don't advertise it because I want to understand use cases people have in terms of. Anyway, if you want to rebuild indexes in automated fashion, we have open source component for you. Fresh one, very interesting, not only for B3, but for any index, almost any. I think Brin is not supported. All others are supported.
I've never seen a bloated Brin index. Have you?
Yeah, good question. It can degrade a lot if you modify. Yeah.
Well, we've got another good episode on that actually. Max Multi, I think, is.
Yeah, on every sentence we say we had an episode already, right? Yeah. Anyway, we're looking for early adopters for this small tool.
Cool. I'll put it in the show notes.
Yeah. Which is open source. Yeah. Okay. Wall write is another one we see often.
Oh, really?
Yeah. Well, again, when somebody hasn't dropped unused and redundant indexes, and they write a lot of. Oh, I forgot to mention. Of course, you can find queries which contribute to this buffer thrashing, right? And maybe get rid of them or make it causing smaller storms, right? So you can optimize queries sometimes and avoid that LWLock buffer mapping contention. Nice. Yeah. So about wall writes, same thing. If you have a lot of indexes which contribute to wall writes, or you have very frequent checkpoints, and you have a random access pattern of writes. When you write to the same page often, but between those writes to the same page you have checkpoint, it means this page will go as a full page write to wall multiple times over and over. Right, you have a lot of wall, and this can be also an issue, right? So and if disks are maybe disk I/O is saturated as well. Yeah, these things.
Yeah, or IOPS. Yeah,
there are several things there. There is I/O wall write, I think, and LWLock wall write. I don't remember from top of my head, but there are interesting nuances there. I probably should cover it someday in Postgres Marathon. Because sometimes you are waiting on disks, but sometimes you are waiting on locking internal structures. Lightweight lock should be that, right? So if wall buffers is there is a quite small amount of wall buffers in the memory. So if it's already fully written, it needs to go to disk. Probably you are waiting on disk. But if you are writing so it should be checked in detail when we have it. There are several wait events there. Also interesting thing which pops up recently is sync-rep, LWLock sync-rep, synchronous replication, when the primary cannot continue because it waits confirmation from replicas, synchronous replicas, right? So
okay, and you're seeing that causing a lot, you're seeing a lot of those.
Not a lot, but this started happening more and more. If you use synchronous replication, quorum commit.
What? Yeah. I come across a lot of people that think they're going to use synchronous replication, but then end up don't. Do you see it quite commonly used?
Let's say so. Big old clusters are on async. All new clusters should be on synchronous replication, although there is a bunch of issues with it. And there was a great talk a few months ago presented by Alexander Kukushkin about misunderstanding of synchronous replication and various anomalies you can experience in current implementation, because it's actually not synchronous replication. This is the thing, because when commit happens, main thing, when commit happens on the primary, it actually happens. It already happened, commit happened. But we just are locked, by the way, on heavy lock, right? Heavyweight lock, on our transaction is locked. And we are waiting for one of replicas to confirm. Or this is actually a lightweight lock sync rep. Yeah, this is it. Yeah, this is it. This is it. We are locked and we are waiting. And when a replica confirms, this lightweight lock released. This is a special case when we need to wait for something outside, which will help us unlock. Yeah.
So I have watched that talk, and I remember a really good slide in it with all of the hops, all of a really good diagram of what actually happens. So yeah, I'll include a link to that.
Yeah, and this how to troubleshoot LWLocks sync rep it's not fully understood. There are interesting new cases which are not covered in articles and talks. I think more materials are coming. I know about some.
Okay.
So, yeah.
Can you share them with me?
Well, it's not. It hasn't happened.
Oh, they
yet.
come. Okay, cool.
Check out upcoming PGConf EU.
Great.
So yeah.
Well, how would you feel about calling the episode there and actually then talking about specifically the lock manager issues in a different episode?
Sounds good. Good idea.
Nice.
Because there are interesting answers inside. Yeah. Great. Let's call it a day for today. I think we covered 1.5%, right? Because it's huge. The list is huge. Some of them I haven't seen ever.
But I think that's useful. I think it's useful to for people to get a grasp on which ones are they most likely to hear.
Main thing always I mention when we talk about lightweight lock and actually weight event analysis, RDS documentation has great list of knowledge and how-to style troubleshooting documents for many weight events, including many lightweight locks. Not all of them, only a subset. But it's great documentation. I hope it will be improved over time, extended, right?
Yeah, it's good.
I know
I'll
it was
link to that as well.
I know a lot of effort was invested to building by many people. I recently reread the blog post by Jeremy Schneider, how it was done during a couple of years. So it was huge effort. That's why it's so good. It's obvious. Short documents, but so much wisdom inside.
Yeah, done over a long period of time, but also by very good people, people that really knew their stuff as well. Yeah, experienced people.
So basically, do this, list of mitigation action items. But behind each step, many RCAs, right?
Yeah.
Cases, case studies. It's so much time paid to just write one line what to do, right?
Mm-hmm.
So, yeah. Or what to check, or how to change, how to improve. Yeah, that's a great example of documentation. Yeah. So that's it.
Well, thanks so much, Nikolai, and
thank you.
Look forward to talking again soon.
Bye-bye.